Good afternoon, students. Welcome to our webinar session. We're discussing ray optics related MSET numerics. We're discussing. So, in the other day, we end with this problem. Just let us conclude this, then we'll proceed. So, in this problem, the asking to find the apparent depth and height, the distances of this bird and fish they are asking. Right. So here the problem is given here in the diagram itself. The whole information is here, and only the formula substitution here. So the formula is, look at this. First, they are asking for what bird, okay, apparent height of the bird with respect to fish. So depth of the bird. See here, actually the height, right? So dy ratio of this refractive indices. It is air to the water. Air that we know 1 and water is given in the problem is 4/3. So substituting these values is 3/4. Yeah, 36 by this one. See, we are getting 48 here. Observe this figure is 48, but actually the length is 36 meters. But you got 48 meters. Then what you observe this means when the observer is in the denser medium, then the object which is in the rarer medium appears with the far distance, with the far to the origin. And similarly, observe this one, the second way, that what is that? Apparent depth of the fish. So the fish is now object and the bird is now observer. Now observer is now in the rarer medium and the object is in the denser medium. Then now how it will be? See the same formula, but now it is what? Ratio of water to the air. Okay, refractive index of water to the air. So formula, here we are calculating the depth of the fish with respect to the bird we are calculating. So the same length here 36 by and refractive index is 4/3. Now we are getting 27 meters. Don't be confused. Here it is 3/4 and it is 4/3. So we are getting 27 meters. So observe this 27 meters is less than the original. The original is how much? 36, but you are getting 27. So what you observe that when the observer is observing from the rarer medium to the object which is in the denser medium, then the length of this will be diminished, minimized. Okay, and yeah, with the help of this information 48 and 27, you can get this information. So 36 plus 48 is the total distance. The fish, the bird. Okay, for the fish, the bird will be observed at a distance. Okay, distance from the fish. The total length is this one. Now the bird. Okay, for the bird, the fish will observe at a distance. Okay, 27 plus 36 is 60. So because it is only due to the changing medium. Now here the problem related to curved surfaces. Here convex mirror has its radius. Convex mirror has its radius of curvature 20 centimeters. Right, find the position of the image of an object placed at a distance 12 centimeters from the mirror. Okay, so here is a convex mirror, right? Observe means the sign conventions are very cautious here. Object is here, is given in the problem. Object is placed at a distance 12 centimeters from the mirror. So object is here. Now to draw the line diagram here, image where it will be the form, right? See, from this object, it's a point object. Minimum two rays are required to draw the image. One ray is passing through the principal axis. One ray is passing through the principal axis, and the other one is here. Okay, the other is drawn just at the surface, and as it is a divergent mirror, then the ray, reflected ray, will be divergent like this. Okay, in this direction. Now, see this ray which is parallel to the principal axis incidents here and reflects, and this ray which is moving incidented at this point is also incidented and reflected, and you can see the two reflecting rays here. One is in this direction, another one is parallel to the principal axis, and if you draw for both the rays, backward rays, for both of them, backward rays, if you draw, means both are appears that coming from this point. You draw the back extension of this ray backward, then this is at this point, and anyway, this ray extension backward is this way, and both are meeting at this point. Here, the image will be formed. Okay, now if the person is observing, okay, from this point, then appears that the image is here. The image is here. Okay, so now this is about the diagram. Now see, the situation is like this. Here u is given already in the problem, that is minus 12. Why minus here? Yes, sign conventions, I told you that light ray is moving from left to right. The light ray is coming from left to right. And all the measurements that we should make from the pole, okay, from the pole, right? So from the pole, the distance means object is at a distance 12 meters is given already in the problem, 12 centimeters. But ray is in this direction, the measurement is in this direction. Ray is coming from left to right, the measurement is from right to left. From the pole, you are measuring the object distance. That's why sign conventions are very, very, very important in this. So light ray is in this direction, and distance you are measuring from pole to this direction, pole to object in opposite direction. So it is u is equal to minus 12. What is u? Object distance. And r value is given, radius of curvature is 20 centimeters, or r value is given, right? This is plus because radius of curvature is inside. Okay, here is the circle shaped radius of curvature will be somewhere inside this. So measurement is from pole to along the direction of light ray. Light ray is moving in this direction, and the center of means the radius of curvature you are measuring from the pole to the right side. So it is a plus 20. So we have a formula 1 by u plus 1 by v is equal to 2r. See, f is equal to, okay, formula is there now, right? So 1 by f, which is 2 by r. So we need image distance. What is asking? Find the position of an image. Find the position of an image. So 1 by v is equal to 2 by r minus 1 by u. And what's that? Yeah, simplify this. You are getting what? 2 by r. R value is given 20. You substitute here minus 1 by u. All u value already is given 1 minus 1 by minus 12. To simplify this, you are getting 11 by 60. Okay, 11 by 60, but it's 11 by 60 is a 1 by v value, but it's asking v value, then it will be 60 by 11 centimeters. And the positive sign of v shows that the image is formed on the right side of the mirror. Okay, so all the signs are very important here. You are getting positive sign over here. V is you are getting in terms of positive, then definitely the image is formed right side of the mirror, because the light ray is in this direction, and in the same direction the image is there. Okay, so the image is formed in the right side, and it is not real, of course, it's a virtual. Really, it's not forming, but appears that both are converging. Actually, it's a diverging. Appears that both are coming from this point. So here we are thinking that it is a image will be formed at this point. So it's a virtual image. And coming to another problem, an object of length 2.5 centimeters is placed. An object of length 2.5 centimeters is placed at a distance of 1.5 f. What is this f? We'll see. I'm repeating, an object of length 2.5 centimeters is placed on the distance of 1.5 f from the concave mirror, where f is the magnitude of the focal length of the mirror. So f is given, magnitude means quantity of focal length of a given mirror, f is given. So focal length is f for this. Now the length of the object is perpendicular to the principal axis. So object length is given 2.5, which is perpendicular to the principal axis. Here it is. The arrow mark is here. It is object whose length is 2.5, which is perpendicular to the principal axis. Right? Now find the length of the image. Okay, find the length of the image. See, is asking about the picture of an image. Okay, so dimensions of an image, what kind of image it is, whether it is a real, erected, inverted, like, right? Of course, it's a real only because it is a concave mirror. Okay, we'll see. Now we'll see that the given situation is like this. The focal length f is already is given in the problem, that f here, and why it is minus here. It is the dimensions are means signs are taken as per the sign convention principles, that light ray is moving in this direction because the object is here, mirror is here. So the object rays can be drawn like this. So from the left to right, and the measurement is means dimensions. All the distances should be measured from the where, from the pole, that is from the center to the left side, means opposite to this direction of light ray. So that's why the negative is taken, and u is minus 1.5 f. U is minus 1.5 f is already is given, and f is given what? Focal length of this one. See, sorry, focal length of this this one, right? So, and what else is given? We have a formula: 1 by u plus 1 by v is equal to 1 by f. What information is known here? Focal length is given, u, object length is given. Object length is f times of, right? 1 by 1 minus 1.5 times of f here, right? So what else we need? 1 by v value is given, is required. See, length of the image is required. Length of the image they are asking. So 1 by v is equal to 1 by 1.5 f minus 1 by f. Understood? So taking out 1 by v, right? The next step will be this, and simplify this. You are getting minus 1 by 3f. So this value is for 1 by v, and where v value is minus 3f. Now magnification, because as given height, length is given, so magnification comes into the picture here. So magnification is equal to, okay, minus v by u is the formula. Okay, so now here the magnification, so heights of the both the image and object, the ratio is here, it is -2. So or simply h2 is equal to 2h1, and this value is equal to, see, is given 2.5. How much it is? H2 is equal, let us take h2 is the image height, is equal to -2 magnification of h1 is the height of the image. H2 is, height of the object. H2 is the height of the image, h1 is the height of an object, and -2 is the magnification. So -2 into h1 is how much? Is 2.5. We are getting -5 centimeters. So this image is 5 centimeters long. This image is 5 centimeters long. Okay, object size is 2.5 and the image size is 5 centimeters. And the minus sign shows that it is inverted. Minus sign. So definitely the object is this side, the image will be formed the other side of this principal axis. Okay, so that's what is the meaning of this one, right? Shall we go for next? Yes. So here is the problem. A rod of length 10 centimeters observe carefully what kind of problems we are solving. The previous problem is the object was with a certain height, and before that was the object was a point object. Now the point is a here object is a linear. Okay. Now a rod of length 10 centimeters lies along the principal axis of a concave mirror. Okay. So the object is now 10 centimeters length, and it is along the principal axis of a concave mirror, and whose focal length is given 10 centimeters, right? In such a way that the end of this rod, AB is the rod, AB is the rod, okay? End of this rod means, let us take this B, is close to the pole, is closer to the pole, okay? So this is AB. Which one is closer to the mirror here? A is B. So B is closer to this. It means this end of the rod is near to the mirror. So to the pole is 20 centimeters. So that the distance is given. What's that? The distance between the mirror to the one edge of the rod, which is closer to the rod. Okay, so that is 20 centimeters is given away from it, and it means what? Mirror. Now find the length of the image. Just is asking length of the image. So in the problem, so look at this. Length of the rod is given total AB, length is given 10 centimeters, and the rod is first surface or first edge of this rod is near to the mirror is at what distance? Is 20 centimeters. Okay, now we don't know where is the center of curvature and all, right? Now we need to find that. And actually what is asking? Find the length of the image. Find the length of the image is asking. Clear? Right. So yeah, so the radius of curvature of the mirror is, right? Radius of curvature of the mirror is, we know the formula. Okay, F is equal to R by 2, or R is equal to 2F. Okay, R is equal to 2F. Formula already we know that. So radius of curvature is equal to 2F. 2F. Okay, so F is already given in the problem. The concave mirror of focal length is 10 centimeters. Then radius of curvature is 20 centimeters. I hope you understood the logic here. Okay, so focal length of the mirror is given, and the radius we got it here 20 centimeters. Now exactly see the figure, 20 centimeters is the length of the first surface, first edge of the rod to the pole, to the mirror. So that is nothing but already is given in the problem 20 centimeters. So what you understood that this edge of the rod is exactly at the radius of curvature of the mirror. So thus the nearer point, the nearer end of the B at of the rod AB is at the center of curvature, and hence its image will be formed at B itself. So the one more point is, when the object is at the center of curvature, the image also forms at the same point but inverted. This point you should understand, you should know, because all these ray diagrams of these spherical mirrors and all you learned in 10th standard only. Okay, so here when the object is at the center of curvature, the image also will be formed at the center of curvature in the inverted form. Okay, so here the image is formed at this point, means for B it will be here. Now we need to calculate for A. So we shall now locate the image of A here. So the dimensions U is equal to, what is U here? Object distance. U is what? Object distance, because A now became object now. Okay, so now the distance is, total length is 10 and this distance is 20. So total distance is 30 centimeters. And for focal length already is given 10 centimeters. Yeah, observe this signs here. Minus sign here given because it is a concave mirror. So all the measurements are from the pole opposite the direction of light. So we have an equation 1 by U plus 1 by V is equal to 1 by U. And substitute the values over there, and you are getting 1 by minus 10 centimeters minus 1 by 30 centimeters, we're getting minus 15 centimeters. Right? So thus the image of A is formed at 15 centimeters from the pole. See, because the negative sign says that what? It is in a opposite this. Okay, left side of the mirror. Right? So length and the image is, yeah, therefore it is a 5 centimeters. Okay, this is the length of the image is 5 centimeters. Okay, I hope you understood this. Now shall we go for the next problem? Yes. At what distance from the convex mirror, imagine, convex mirror of focal length is 2.5 meters, should a boy stand so that his image has a height equal to half the original height? I'm repeating, at what distance from the convex mirror, means at what distance the boy should stand so that his image has a height equal to the half of the original height. I'm repeating, the boy is standing, okay, in front of the convex mirror so that his image has a height that should be equal to half of the original height. This is the problem. I'm repeating, the boy is standing in front of the mirror and the image should be half of the original height, so that the principal axis is perpendicular to the height. That's okay. And what information is given? Focal length is given. Focal length is given. And lens mirror is what kind of mirror it is? Convex mirror. So the focal length is 2.5. And what information we have? Magnification length. Magnification should be what? The image. The size should be half of the original, right? Magnification should be half of that, right? So magnification is 1 by 2. And what else information is given here? The image distance. Okay, image size is half of the original, half of the object. So u by 2. Okay, right. Now also we have the formula 1 by u plus 1 by v is equal to 1 by f, and we need what? 1 by u. Okay, 1 by u we require, that is object, right? U is equal to, so simplify this, that you're getting 2.5 meters. Okay, so substitute all the values here. 1 by u plus 1 by v value you got here minus u by 2 is equal to, simplify this, you are getting, wait. The focal length is given 2.5. Yeah, so 1 by f, substitute the value here, 1 by 2.5. Yeah, from this take out 1 by, yeah, it is 1 by u plus, means minus 1 by u by 2. This value you are getting minus 1 by u. Okay, simplify this, you are getting minus 1 by u. Then, so minus 1 by u is equal to 1 by 2.5. So now, so yeah, 1 by u is equal to 1 by 2.5 means u is equal to minus 2.5. Yes, sir. So yes, thus he could stand at a distance of 2.5 meters from the mirror. Okay, understood? So the distance of an object means where the person should stand here is at a distance from 2.5 from the mirror. Okay, right. Now we'll go for the one more problem. Very cautious while substituting, and the negative signs. The signs are very, very, very important. Right. We'll go for the next problem. A 2 centimeters high object is placed on the principal axis of a concave mirror. Concave mirror. At what distance of, at a distance of 12 centimeters from the pole. I'm repeating, a 2 centimeters height object is placed on the principal axis of a concave mirror, right? Which is at a distance of 12 centimeters. Height is given, distance is given. Means object distance is given, u is given from the pole. If the image is inverted. The image is inverted, real, and 5 centimeters height. I'm repeating. Object height is 2 centimeters and U is 12 centimeters. If the image is inverted, real, and 5 centimeters height, find the location of the image and focal length. Location means what? V is asking, and F also asking. F of the focal, F of the mirror. Understood? Yeah. So the magnification formula M is equal to minus V by U. This is the information is given in the problem. Okay. So object distance is 2. Image distance that we need to calculate. The distance U distance is 12. And the object height is 5. No, sorry, image height is 5. Image is real, inverted, and the height is 5. And the object is here, height is 2. And this object is at a distance 12 from the mirror. This is the information is given in the problem. Now look at this. Magnification, how you can calculate this? Here it is. Minus 5 by 2. That is equal to V by U. V that we need to calculate, and U is given 12 centimeters. That is minus. Look at this, how minuses are came. It is a concave mirror. All the measurements are left side from the mirror. Okay. Now, yes, simplify this. You're getting 2, 1.2. Yeah, you see, you're getting 30 centimeters. So, V is equal to minus 30 centimeters again. So the image is formed at 30 centimeters from the pole. I'm repeating, the image is formed at 30 centimeters from the pole on the other side of this one. Okay. Now we have what else information we got here? V got. V distance we got. Okay. Image distance we got. Right. Now focal length. So 1 by F is equal to 1 by V plus 1 by U. 1 by V plus 1 by U is the formula. Focal length we need to calculate. Okay, so 1 by V is how much? 30. And 1 by U is how much? Is 12 already is known. So simplify this. You are getting 7 by 20. Then this is 7. This 7 by 20 is the value for 1 by F, and F is equal to 60. Sorry, 7 by 60 and 60 by 7. So simplify this. We're getting minus 8.6 centimeters. This is the focal length of the mirror. Okay, so substitution, formula substitution here, all are logically given. Okay, so observe the logic and find out. Okay, using the formula very cautiously. Now we'll move to the next problem. The angle of minimum deviation, from a prism is 37 degrees. If the angle of prism is 53, find the refractive index of the material of the prism. The whole information is given, just they are asking refractive index of the prism. I'm repeating, angle of minimum deviation delta value is given 37 degrees. And angle of prism capital A value is given 53 degrees. And they are asking to calculate the refractive index. Refractive index formula is there. Mu is equal to sin I by sin R. Okay. So sin I, already we discussed. Okay. The synopsis of this one, dispersive power. So mu is equal to sin I by sin R. So sin I value is A plus dm by 2. Dm means minimum deviation by 2. And A by 2. A is what? Angle of prism. Okay. So A is 53 is given. Minimum deviation is given 37 by 2. And sine A by 2 is sine 45 by sine 26.5 degrees. So for these values, you need to go for logarithmic values here. Okay. You should understand logarithmic values, how to go to the get the logarithmic values. Okay, try to learn that also. So otherwise, in the examinations for these degrees and all, it's a very advantage in learning this logarithm. Okay, so this is here 1.5. So it is a direct substitution form. Okay, I will go for one more problem. A concave mirror having a radius of curvature 40 centimeters is placed in front of an illuminated point source at a distance of 30 centimeters from it. Find the location of image. Yeah, what you understood here? Radius of curvature is given R value 40. At a distance 30 centimeters means U value is given. As it is a concave mirror, it will be negative, opposite side, right? And what is asking? Find the position of an image means distance, V value, image distance, V value. So here is the formula. 1 by V plus 1 by U is equal to 2 by R. Okay, directly substitute all the values here. 1 by V is equal to 2 by R minus 1 by U. So 2 by minus 40 minus 1 by U is how much? Minus 30. So 1 by V is equal to, so multiply this, 30 plus minus 20. Yeah, yes. Okay, minus 30 plus 20 by 13. So this is the simplification that 1 by 60 you are getting. Okay, minus 1 by 60 you are getting. So if it is a minus 1 by 60 value is equal to 1 by V, then V is equal to minus 60. So the image will be formed at a distance of 60 centimeters in front of the mirror. So what minus sign here? It is left side of the mirror because it's a concave mirror, left side of the mirror. Okay, because I'm taking number of models from the almost, because if you refer old papers, either NEET or MSET, the most of the problems will ask from this plain mirror concepts, mirror and lens concepts. Okay, right. Here one more model, that a concave mirror forms an image of 20 centimeters high. Concave mirror forms an image of 20 centimeters high. Object on the screen placed 5 meters away from the mirror. The height of the image is 50 centimeters. Image is the height. Find the focal length of the mirror and the distance between the mirror and the object. So U value you need to calculate and F value you need to calculate. So the concave mirror forms an image of 20 centimeters high. Okay, right. On the screen placed, the screen is placed at a distance 5 meters away from the mirror. Then the height of the image is 50 centimeters. Find the focal length and the distance between the mirror and the object distance here. So here is the problem. H1 is 20 centimeters. H2 is 50 centimeters. Right? H1 means what? Concave mirror forms the image. H1 is the image height. And 50 is what? The height of the image is 50 centimeters. Okay, height object. Right? The concave mirror forms an image of 20 centimeters height object which is placed at this one. Right? So H1 is 20, H2 is 50, V is given 5, okay, minus 5 centimeters. M will be what? 500 centimeters. Okay, this is what magnification we are getting, right? So since minus V by U is equal to H2 by H1, H2 by H1. Okay, right? Because the values are given in meters that they convert into centimeters. Okay, so 500 centimeters. So minus V by U is equal to H2 by H1. So 500 by U is equal to 50 by 20 because the image is inverted. This given image is inverted. Clear? Right. So from this we need u value. So u is equal to 500 into 2 by 5. 0, 0 cancels 2 by 5. So here this will be cancelled 200 you are getting centimeters. So convert that into meters is minus 2 meters. Now what you get? U value, that is object distance you got. Now is also asked to calculate focal length of that mirror. And what information we have? V is there, U is there, and we have a formula 1 by V plus 1 by U is equal to 1 by F. Right, substitute the values, both are minus only. Yeah, okay, so both are because which mirror it is? Concave mirror, so left side, so all are negatives. So 1 by F is equal to, so if you simplify this, you are getting 7 by 10. Yes, 7 by 10. So 1 by F is 7 by 10 and F is equal to 10 by 7 minus will come this side. So F is equal to 10 by F and you are getting minus 1.44. And this is the focal length of a given mirror. Okay, find the focal length of the mirror and the distance between the mirror and the object. Mirror and the object. Mirror and the object means what? Object distance you are getting 2 meters. Okay. And you will see one more problem here, right? A light ray falling at an angle 45 degrees. Try to understand the problem cautiously and keenly. A light ray falling at an angle of 45 degrees with the surface of a clean slab of ice of thickness 1 meter is refracted into it at an angle of 30 degrees. So angle of incidence is given 45 and angle of refraction is given 30 and the thickness of that slab is given 1 meter. Imagine the figure. Now calculate the time taken by the light rays to cross this slab. Understood? Calculate the time taken by the light ray to cross this slab. Refracted angle is given, incident angle is given, then at what time it will take to reach the other side of the slab they're asking. Okay, now speed of the light in vacuum already is given. It's a fixed one, 3 into 10 power 8 meters per second. I hope you understood the problem. Now I will proceed for the answer. Right? So we know sin I by sin R formula. Okay, sin I by sin R is equal to velocities of both the media. That is, one is inside, means is what they're asking, calculate the time taken by the light to cross the slab, means in that slab, inside the slab, at what velocity the light is moving, that we should understand. First, if you calculate that velocity inside the body, velocity inside the slab, okay, we know the velocity outside, that is air, this is given, and inside this velocity that we don't know, right? So sin I by sin R is equal to, so velocity of air by the velocity of a medium, right? This is what? Refractive index. Sin I by sin R is nothing but refractive index. And very beginning we discussed refractive index is equal to C by V. Remember or not? So sin I by sin R is nothing but mu is equal to C by V. C is the velocity of light in air to the velocity of light in medium, V. So sin I is given in the problem 45 degrees, and sin R is given angle of refraction is given 30 degrees. Okay, substitute the values here, that is 1 by root 2, okay, 1 by root 2 whole by 1 by 2, then you are getting, yes, 2 by root 2 is equal to, yeah, if you cancel this, yeah, further simplification, right, you are getting root 2. So 2 you can write as a root 2 into root 2 and root 2 gets cancelled, you are getting root 2. Now, what you're getting here? 3 into 10 power 8 by V is equal to root 2 you got. Okay, so from that, V is equal to 3 into 10 power 8 meters per second by, okay, how much it is? Root 2. Root 2 value is, you substitute that value, root 2 value, and cancel them, you're getting some value. And yeah, that V value you're using, going to further use, because what they're asking, time taken is asking time. So value for time, formula for time is what? Distance by velocity, right? Distance or displacement by velocity. So we got velocity here. We got velocity here. Now distance we need to calculate. Distance means length. Okay. 1 meter thickness is given. 1 meter thickness is given here. Right. So within 1 meter, it is how much distance is covered, means it is refracting inside the medium. It is refracting inside the medium. So how much is refracted? 30 degrees. Refracted into it is angle 30 degrees is given. So cos 30. So x is equal to distance. X is equal to 1 by, what is this 1? Is the thickness of the slab. So 1 by cos 30. That is a 2 by root 3. Okay. Now this is what distance, okay, traveled inside the, means with this much angle, while it is refracting with this much angle. So the distance is this much is covered, 2 by root 3 meters is covered. Now, so time taken is equal to distance by velocity. So 2 by root 3 into, by means, so this is coming like this, okay, root 2 by 3 into 10 power 8. So root 2. Okay, so after simplifying this, we are getting 0.54 into 10 power minus 8 time, no, seconds. Okay, or simply you can write 5.4 into 10 power minus seconds. So this is what, how to calculate the time. And now one more problem. An object is to be seen. An object is to be seen through a simple microscope of focal length 12 centimeters. So there is a simple microscope. We discussed in the regular class that an object is to be seen through a simple microscope of focal length is 12 centimeters, where should the object is to be placed so that to produce the maximum angular magnification. Okay, so the least distance for distant vision, clear vision, is 25 centimeters. Means capital D value is given. Okay, focal length of this microscope is given 12 centimeters. And where should the object be placed so that to produce maximum angular magnification? For getting a maximum magnification, where the object should be placed? Where the object should be placed? Okay, usually the lens is between the eye and the object. Okay, so for getting the maximum magnification, where the object should be placed, this is what is asking, right? So here is the solution. For a given simple microscope, least distance of distinct vision is B is equal to 25 centimeters and F is equal to 12 centimeters is given focal length of that microscope. Now, for maximum angular magnification, the image should be produced at least distance of clear vision. So V is equal to D, where we should keep the object for best means maximum magnification is 25 centimeters. That V, yeah, from the lens it is Measuring is left side. Okay. So least means at what distance you are keeping the image. The image should be produced at the least distance. See, for normal eye without any defect, for eye, it can see the clear image at what distance? Least distance of distant vision only, 25. That's what is asking. For maximum angular magnification for clear image to be produced at least at a, which distance is least distance of distant vision, that is 25 centimeters. So image distance became least distance of distant vision. So V is equal to D. So F we got, V we got, yeah, and we need to get a U value, object distance. That's what he's asking. Yes or no? Where should the object is placed so as to produce minimum angular magnification? Okay, so we need object distance, right? So 1 by V minus 1 by U is equal to 1 by F. This is length, so minus will come. So 1 by V is equal to, like this, 1 by U. So 1 by U is equal to 1 by U is equal to 1 by V plus 1 by U. The printing mistake. Okay, 1 by U is equal to 1 by V plus, this is coming this way, no? So 1. So 1 by V, how much it is? 1 by minus 25 minus 1 by F is how much? 12 is a 1 by 2. Y minus focal length is left side, right? So yeah, simplify this. You're getting simplify this. You are getting 37 by 300. So further simplify that. 37 by 300 is what? 1 by U value, and U is equal to 300 by 37, and you are getting 8.1 centimeter is the object distance should be kept in front of the lens for the simple microscope. For the simple microscope. Understood? Yes. And we have one more problem, right? Mostly this is the last problem. You see, now a thin prism is made a material having refractive indices 1.61 and 1.65 for the red and violet light. The dispersive power of the material is 0.07. It is found that a beam of yellow light passing through the prism suffers a minimum deviation of 4 degrees in favorable conditions. Calculate the angle of prism. Right? A thin prism is made up of a material having refractive indices 1.61 and 1.65 for a red and violet light. The dispersive power of the prism is given 0.07, and it found that the yellow beam is passing through the prism that suffers the minimum deviation. Means yellow line having the minimum deviation is given 4 degrees, and dispersive power of the material is given 0.07, and the refractive indices of the prism is given 1.61 and 1.65. And what they're asking, angle of prism, that is capital A value they're asking. Yeah. So capital A value they're asking, right? And yeah, given that refractive index of R means red and refractive index of violet, is that so? Violet and red, yes, right? And omega, what is omega? Dispersive power. And delta Y means what's that? Angular displacement of minimum deviation of yellow color, minimum deviation of yellow 4 degrees. Okay, this is the information, and we have a formula. This is what? Omega is equal to mu v minus mu r by mu y minus 1. Already we discussed in the morning. Okay, right. So what is that? Dispersive power is equal to, so dispersive power already value is given 0.07. Okay, substitute all the values here. Yeah, this value. Refractive index of y is given, no? Yellow is given or not? minimum deviation. Oh, yeah. Okay. So take out this one, mu y minus this side. Okay. So 1.65 minus 1.61 is 0.04 by 0.07. You're getting 4 by 7. That is mu y minus 1. You're getting this value 4 by. And we have a formula for what's that? Minimum deviation delta is equal to mu minus 1 into a. The direct formula is there, and we are getting directly mu y minus 1. So this is what a we need to calculate. A is equal to delta, that is minimum deviation of y by, means yellow, by mu y minus 1. So substitute the values here. This is how much is delta y is given in the problem 4 degrees, and this value we got 4 by 7. So 4 by 4 by 7, we are getting 7. So this is what 7 degrees. Okay, this is what angle of prism. Okay, now let us conclude with this assignment and try these assignments. Okay, practice these problems, right? Okay, so keep in touch with the subject, and go deep into the concepts for who is preparing for NEET or NSET. Go depth into the subjects, so then only you can understand the problems. Okay, so let us conclude this session. Thank you. All the very best to all. Thank you.